Hello, Lovelace, and welcome to today's maths lesson. We're carrying on with our work on fractions today with the question, can I recognise equivalent fractions? Okay, that's our key word for today, equivalent, and I'll explain its meaning in a moment. Apparently, talking to Mr. Burford, Mr. Hill, you've done a little bit of work on equivalent fractions before. So here's your little warm-up. Can you put a greater than, an equal, or a less than symbol between these four sets of fractions? Pause the video, have a go. Right, well, the first one, 1/4 and 1/2. Basically, what we're saying here is the whole one has been split into four equal pieces, or the same whole one has been split into two equal pieces. Well, if it's only been split into two pieces, those pieces are going to be bigger than if we'd split it into four pieces. So a half is greater than a quarter, or quarter is less than a half. What about this one? The whole has been split into two equal pieces, or the whole has been split into 14 equal pieces, but we've got 7 of them. Hopefully you've recognized that 14 is double the 7. So this fraction is the same as, it's equivalent to a half. So a half is equal to 7/14. What about number 3? Bit trickier now. Well, if we look, first of all, at 13/26, you'll notice that 26 is double 13, or 13 is half of 26. That means that that fraction is equivalent to a half. But what about this one, 15/31? Well, 15 is less than half of 31, which means that 15/31 is less than a half. So 13/26 is greater than 15/31. And finally, we've got 3/5 and we've got 2/5. So in both cases, we've split our whole one into 5 equal pieces, but this time we've got 3 of them, and on this side we've got 2 of them. Hopefully, quite clearly, this side is bigger. So 3/5 is greater than 2/5. Right, so equivalent simply means equal to, or the same value as. Okay, it's the same amount. A half is as big as 2/4. Okay, if you had a pizza and you were offered half a pizza or 2/4 of a pizza, you'd actually be getting the same amount. It's equivalent, it's the same as, it's equal. Okay, so a reminder from last time as to how we build a fraction, the vocabulary we touched on last time. So first of all, our bottom number. This is the denominator, and this tells us how many equal parts there are, how many equal parts the object has been split into. The top number, can you remember its name? The top number is the numerator, and that tells us how many parts we're using, how many have been shaded, how many we've eaten, or whatever the question is. So how many we're interested in. Now, first of all, is this 4/4? Hopefully you're screaming at the screen right now. No, because they're not equal parts. Now they are. So now we are looking at quarters. Okay, and 1/4 would look like that. But in just the same way, that's 1/4, that's 1/4, that's 1/4, and so is that. Doesn't matter which one is shaded, doesn't matter which one we're interested in, as long as there's just the one of them. Okay, here we've got 2/8. So there's our bar, same length of bar, so it's the same size hole, and the whole has been split into 8 equal pieces. And we're going to shade 2 of them. There we go. You notice anything? Hopefully you've noticed that it is the same amount of shading. So 2/8 is exactly the same amount. It's exactly the same size as 1/4. Hopefully you can all see that. Okay, so that means that 1/4 is equivalent to 2/8. It's equal to. Or, looking at the other way, 2/8 is equivalent to 1/4. So a question for you, is 6/9 equivalent to 2/3? Let's have a look. Well, here's our whole, and it's been split into 9 equal parts, and 6 of them have been shaded. So this is showing us 6/9. Here's our thirds, 3 equal pieces, and 2 of them have been shaded. So here's our 2/3. And you can quite clearly see that these are the same size. So 6/9 is equivalent to 2/3. And 2/3 is equivalent to 6/9. It works both ways. Right. Pause the video and have a think. Which of these is the odd one out? Right, well, let's have a look. There's 4/9, 9 equal pieces, and 4 are shaded. There's 6/9, 9 equal pieces, 6 are shaded. And there's 4/6, 6 equal pieces, 4 are shaded. Now, hopefully you can see that these bottom two are equal in size. The top one, the 4/9, is quite a lot smaller. So these two, 6/9 and 4/6, are the same. They're equivalent. 4/9 is quite a bit smaller. So that one is the odd one out. Right, you may have seen one of these before. This is a fraction wall. We've got our whole at the top, and then in each row, our whole has been split into a different size of fraction. In the second row down, it's been split into 2 equal pieces to give us halves, then 3 equal pieces for thirds, 4 equal pieces for quarters, and so on, all the way down to 12 equal pieces to give us twelfths. And it allows us to compare fractions with each other. So if we look at this dotted line here, you can see we've put the dotted line at 1/6, and if we follow it down, we can see it crosses this line here as well at the bottom, and it shows us 1, 2 twelfths. So 2 twelfths is equivalent to 1/6. They're the same. Okay, so 1/6 is equivalent to 2 twelfths. What about this one? We've got 3 quarters here. So if we draw a dotted line, and let's see where it crosses. So follow this down, and you can see it crosses here on the 8ths row. 1, 2, 3, 4, 5, 6 8ths. And then again, it crosses at the bottom on the 12th row, 9 twelfths. So 3 quarters is equal to 6 8ths. It's also equivalent to 9 twelfths. Okay, we can also say that 6 8ths is equivalent to 9 twelfths. These 3 fractions are all the same size. What about 2/3? So we're looking here. 2/3, have a think. Where does that line cross on its way down? If we put it in, you can see it crosses here at 4/6. 1, 2, 3, 4, 6. It also crosses here at 6/9. Does it cross anywhere else? It does. It crosses down here at 8 twelfths. So 2/3 is equivalent to 4/6 and 6/9 and 8 twelfths. Right, your turn. Pause the video now. Question 1 is all about shading the right amount in each of these bar models. Question 2, using the bar models to help you complete these fractions. And question 3, labeling a fraction wall and then using that information to help you. Okay, so pause the video, have a go. Right, here are your answers. Please mark your own work. 1/8, there's 1/2, there's 3/6, and you can see that they're the same size, they're equivalent. On B, there's 1/2, there's 5/10. Again, you can see it's the same size. On C, 4/5 and 8/10. Again, if your shading isn't coming out as being the same size, then you need to double check you've made an error. And D, We've got 6/8 there, and that's equivalent. It's the same as 3/4. Using our fraction wall on number 2, we can see that half is the same as 2/4. A half is the same as 4/8. 2/4 is the same as 4/8, 4/8. 2/8 is the same as 1/4. All these lines are lining up. On E, 6/8 takes us to there. That's the same as 3/4. And F, 2/2, is the same as 4/4 or 8/8. In each case, it's a whole one. Then labeling the fraction wall, you just need to look at those answers. We've got 3/3, we've got 6/6, and we've got 9/9. And that information will lead you to 1/3 is the same as 2/6 and 3/9. 2/3 is the same as 4/6 and 6/9. And 3/3 is the same as 6/6 and 9/9, which is equal to 1. Okay, well done if you've got those. Okay, 3 choices of answer now. Always, sometimes, or never. The answer, the statement is always correct. It's sometimes correct. It's never correct. Okay, the greater the numerator, the greater the fraction. What do we think? Right, well, there's one example, 1/7 and 4/7. In this case, 4/7 is bigger than 1/7, and it's got a bigger numerator as well. But is that always the case? There's the 1/7, there's the 4/7. So in this example, then yes, the larger numerator is the bigger fraction. But what about here? Our larger numerator is here with the 2. So, but here's 1/3, and there's 2/10. And hopefully you can see that the 1/3 is bigger. So in this case, the greater the numerator, the greater the fraction is sometimes true, but not always. There's an example where it's not true. So sometimes. Right. Here's your questions. In a moment, I'll ask you to pause and have a go. Number 4, here's a fraction wall. True or false? Are these fractions equivalent to each other? So check using the fraction wall. And then write your own equivalent fractions. And ask someone in the house, I know you don't have a partner necessarily, to see if they understand whether they're true or false. And then on number 5, are these statements always, sometimes, or never true? And if you can draw a diagram to support and explain your answer, that will be fabulous. Okay, so pause the video, have a go. Here are your answers. So a half is equivalent to 3/6. That's true. 2/3 equivalent to 3/4 is false. 2/4 equivalent to 3/6 is true. 2/3 equivalent to 4/5, that's false. 2/3 equivalent to 4/6 is true. 3/5 equivalent to 4/6 is false. So we've gone true, false, true, false, true, false. Okay, I'll take a look at your examples when you upload onto Tapestry. For now, we could have lots and lots of different answers for that one. Number 5, always, sometimes, or never true. The first statement, the greater the numerator, the greater the fraction, is sometimes true. That's the one we looked at. So in this case, 4/5 is greater than 1/5. But 1/2 is greater than 2/5. So sometimes that can be true, sometimes not. B, fractions equivalent to 1/2 have even numerators. Again, that is sometimes true, because half is equivalent to half, and that's got an odd numerator. 3/6 is equivalent to a half. That's got an odd numerator, but 2/4 is even. 4/8 is even. So that's sometimes true, but not always. And then finally, if a fraction is equivalent to 1/2, the denominator will be double the numerator. Absolutely, that is true. So 1/2, 2 is double 1. 2/4, 4 is double 2. 3/6, 6 is double 3. 14/28, 28 is double 14. In each case, these fractions are equivalent to a half. So that is absolutely always true. Okay. Well done today, guys. You worked really hard. Time for a break. Make sure you look after yourselves, stay safe, look after those around you, and I will see you very soon.